is Abhishek. Work on a bunch of things, bunch of different companies, bunch of different roles, bunch of different cloud providers. Not here for that, so I'll skip that part. And feel free to connect with me. I'm always happy to, chat with you folks. This is about you now. So I know we have people coming in, but quick show of hands here for folks who work on machine learning, or perhaps you are lucky enough to be asked to work on generative AI. Expert or not doesn't really matter, but you have been probably working on machine learning for a while. We have 4 or 5 hands, I guess. Okay. All right, 7 or 8 hands. Okay. Not a lot. Okay. I guess that sort of aligns with my experience as well. So to be very, very honest with you, I am not a machine learning expert myself. I am more of a sort of backend engineer working on databases, programming languages, app dev platforms, serverless, containers, so on and so forth. But apparently AI can do all of that now. So I had to save my job. And I guess one way to do it is to learn AI, generative AI, I guess. Yeah. Keep your friends close and your enemies closer. I guess that's how it goes. Anyway, jokes apart. Really what pulled me into generative AI was this thing called vector databases, right? And when I was trying to initially, and all of us had a mandate, right? GenAI is going to be the focus. So, I kind of did the same, like probably most of you folks. And I was trying to find an overlap, which naturally was, in my case, databases and vector databases in this case, right? So that's what I'm going to spend my time today talking about. I have less than 30 minutes now, so time is limited. And I have 3 demos as well, so hopefully things all go well. So that's sort of my agenda for you today. And before I do that, pretty much everything I'm going to talk about is available as a blog post. These slides are linked there. There is a GitHub repository. I've kind of written down a summary of the talk as well. If folks, for someone who is not here, they can refer to the slides, and if they don't have the video for whatever reason, they can read that summary of the talk. So everything is pretty much here, and so I'll pause for a few seconds for you to capture this if you're interested. So you don't really need to take pictures of slides and so on and so forth if you don't want to. So that's that. Few more seconds. This is important. All right. If anyone needs more time, let me know. I can go back, and you'll find this that QR code later on as well. So not to worry. But just to set the context real quick, right? These foundation models, you might have heard of this term called foundation models. They are a class of machine learning models, and they are pre-trained on huge amounts of data, structured, unstructured, so on and so forth. And they are these, everyone tends to call them the heart of generative AI. And then there are these things called LLMs, or large language models. Not diving deep into them, but they're kind of a category or a class of foundation models. Okay. And these models are, like I said, very, very, powerful, and you've probably been using them actually. So think about the Claude family from Anthropic, right? I don't know if you have used them, Claude Sonnet, Claude Haiku, etc., right? And Claude V1 and V2, I guess a few months back. There's Mistral AI. There is Llama family of models from Meta. I think Llama 3 got released. Was it yesterday or day before yesterday? I find it very, very hard to keep pace. They're like these JavaScript frameworks. I'm not a JavaScript developer either, but then, pretty much each day there is a new, there used to be rather a new JavaScript framework. So, and typically, and this is not always the case, one would use these models or invoke these models via managed platforms. Not always, but, most of the time, at least for production use cases and, things of that nature. And Amazon Bedrock just happens to be one of those sort of managed platforms which has a wide variety of models which you can access via a unified API. But these models are very, very powerful, and you could actually sort of use these as your standalone go-to tool for building generative AI applications. So why are we here? Why am I here, and why are you here listening and talking about vector databases and things of that nature, right? So for that, we need to step back and sort of get more context in terms of limitations of LLMs or large language models. Now I'm going to talk about just a few common ones. We cannot cover everything, obviously, 30 minutes. So this is one of the examples, right? So if you look at the first sort of interaction I have, at the top here. So the model comes back with this response. It says, hey, you know what? My training data is only up to date up until, in this case, it's January 2022. could be anything else. So I am not able to give you this answer because apparently you have asked me something about an event in 2023. That's fine. That's honesty, and I really, I guess all of us respect that. Okay. But the second scenario, the second interaction is a bit more worrying, at least for me, and I guess for a lot of you folks. And this is referred to as hallucination, where the large language model, and I guess you would have heard in the keynote as well, there are various ways, sort of to think about large language models. Some people call them, I think in the keynote, I forgot the exact terminology. But anyway, they are these excitable creatures, right? They want to help you. But very often what they do is they give you a wrong answer very confidently. Now, we all know the answer to this, that it's simple enough, but obviously most of the instances we go there because we probably don't know the answer, right? So that's the problem. So the first thing is the issue of knowledge cutoff or training data dates or sort of cutoff dates, and the second is hallucination. And the other common one is this point of the large language model not having access to external data. Now you can imagine, this is not very hard to imagine. The large language model cannot know about your specific use case, your specific domain, your private company data. It doesn't really know that, right? So basically, there are a lot of ways to sort of work around these constraints or limitations of large language models. There's sort of, there's a spectrum, so to speak, right? So there's prompt engineering, fine tuning, so on and so forth. And these actually have their own pros and cons depending upon, in the context of, say, effectiveness or cost efficiency and so on and so forth, right? So what we are going to be discussing today is this technique called RAG. And I think you might have heard of it already. It's already out there. It's not novel or new. And it's called retrieval augmented generation. It's a mouthful. I always struggle, but at least in this case I didn't. So that's what we're going to talk about today. And when we talk about RAG, one of the very core or foundational elements is this thing called vector databases, right? And that's how we sort of come to this sort of overlap. And if you want to talk about vector databases, I think it makes sense for us to understand what vectors are. Probably you folks know it, but it's always good to have a refresher. Very simply put, right? In a very simplified language, vectors are nothing but numerical representations of text. Now, these actually don't need to be text. Think of them as numerical representations of data in general. It could be non-textual data, it could be video, it could be audio and image and so on and so forth, right? And if you look at this illustration on the side, it's again, like I said, an overly simplified view. Think of your input, your text, often called a prompt when you talk about in the context of a large language model. So you have an input text or a prompt, you pass it through something called an embedding model. This is not the same as a large language model. This is sort of a different category of model. And now you can sort of, again, for a simplified view or understanding, think of this embedding model as a stateless function. You give it an input and it gives you an output, and that output is, again, an array. Very simplified terms, array in any programming language, right? So it's an array of floating point numbers. That's pretty much it in terms of understanding the core principle of vectors and vector embedding, of course, in a very simplified way, right? And these are also called embeddings. So vectors, embeddings, you are going to sort of hear these words interchangeably, okay? But what's important to understand is that these vectors or embeddings, they have semantic meaning, right? And you can look up this word semantic later on, but in plain and simple words, these vectors can help you go beyond just simple text search. It's not like, I search for Abhishek and I get occurrences of paragraphs or content where the word Abhishek is there. They are meant for contextual search. They are meant for relevance-based search, right? So that's something very important to understand when you think about vectors and embeddings and why they are potentially, so hot right now and so important, right? I think these concepts are, I guess, 30, 40, 50 years old, I don't know, but they are coming into limelight because of generative AI and so on and so forth. So that's that. Oops. Okay, and when you think about vectors and then come to vector databases, it's kind of obvious that vector databases are specialized to store these vectors. Okay, now they are not special databases in any way. You store these vectors, you query these vectors through SDKs and query languages and so on and so forth. You scale these databases, you shard them and so on and so forth, just like you would with any other database for that matter, right? Now, my mental model of vector databases, at least at a very, very high level, is to sort of categorize them into two parts, right? One of them is these existing databases which have extended vector search support by having special data types, right? So, for example, in Postgres, there is an open source pgvector extension, okay, which is supported via, in this case, I just have a few AWS native databases examples here as well, just as equivalent, right? So that's supported in Aurora. MongoDB has something similar, supported in Amazon DocumentDB, and the same includes with Redis vector search. MemoryDB for Redis has that in preview as we speak, and Amazon OpenSearch, etc., right? So this is this existing category of databases, very popular. We probably we have used them in our production applications somewhere as a part of our architecture, right? And then there's this category of specialized data stores. At least I tend to call them like that. And the examples include Pinecone and Milverse and VV8 and so on and so forth. And these are a very, very limited set of examples. This field is evolving very, very quickly, and I expect, like, literally there is a vector database every week, at least when I see, right? Again, it's very hard to catch up for me as well. Now I'm going to move to the demo part very soon, but then before that, I want to again give you this big picture. Now, vectors, vector databases, and generative AI. But how does a vector database sit in the context of a larger generative AI solution? Something which is important for you folks for everyone to visualize and to be able to appreciate some of the things. So moving from left to right, you have your raw data. Like I said earlier, it doesn't need to be text. Yes, it can be text, PDF, plain text files, CSVs and whatnot. But it can also be images. It could be video or audio and so on and so forth. So the first step is you actually chunk them or split, because these often tend to be very, very sort of large, at least for production applications. You split them into smaller pieces, often called chunks. The process is called chunking. And then there is the embedding process. You pass them through this, something called an embedding model, like I alluded to earlier. And out comes your vector embedding. Store that in a in a vector database, depending upon what you're using. And ultimately, how this is used in the context of applications is applications would query this vector database. Typically, what it's called is semantic search. That's the terminology. And then from the results which you would get, they're typically these top n results, top 3, top 5, top 10. Give me top 5, XYZ. So that's typically how you sort of frame your analogy when you work with these semantic search and vector databases. And then it doesn't end there. You combine these search results, this semantic search results in various ways in other parts of your application as well. And I'm going to show that to you, of course. But before that, I'll show you the demo, and I'm sort of going to move progressively as we sort of build this solution. So the first demo, this is with Amazon OpenSearch service, which is the managed version of the open source OpenSearch, which is a search and analytics engine. And the other one is LangChain. LangChain, I don't know if folks, have you heard of LangChain? Anyone? Okay, few of you. Okay. So LangChain is an open source framework for building, I guess, generative AI applications. That's very high level sort of title, but then it sort of helps with prompt engineering, LLM orchestration, so on and so forth. So it's like a toolkit. So I'm going to combine both of them, and I also I've used Streamlit as well. Maybe you folks have already recognized this as a Streamlit interface. So that's that. And I'm going to show you the demo, mostly not dive into the code, so on and so forth. Again, 30 minutes is all I have, and 3 demos. So for more info, this is the link to the same blog post, which I pointed to earlier as well. Okay. So I'll take a sip and then move on to the demo. So this is semantic search, by the way. I'm going to move into my IDE now. All good. Let me bump up the font a little bit. Is this okay? Or yeah. All right. So what I'm not going to show you, like, go through the console again, not waste time there. But for context, what I have ready and loaded into the Amazon OpenSearch vector database engine is this data called the Amazon shareholder yearly shareholder letter. This is from 2022. The 2023 one was released, I guess, a few days back. But anyway, so I have this PDF data already, chunked up and loaded into OpenSearch. So that's that. And what I'm going to do is execute semantic search based on this data, using this as this PDF file as my data source. Okay, so I'm going to scroll down, and I'm going to run the Streamlit application which we have. So Streamlit it's actually, I'm not a Python developer, by the way, at least not a hardcore one, right? So but I really found Streamlit to be very easy to use, right? It can, like with a few lines of code you can come up with this wonderful front end applications like this, which again, for a backend developer like me, it's even simple ones are hard to build. Okay, so what I'm going to do is ask a question, hit go, that's all. So what is my question in this case? What is Amazon doing in the field of generative AI? Now, what this is going to do, this is going to refer to that document which I spoke about, that shareholder letter data, and let's give it at least a few seconds. So this is all in real time. Obviously, it's connecting to the OpenSearch and whatnot. It's all simple Python code. You can refer to it later. So what it did was it came back with a bunch of search responses. In this case, we all start with index 0, right? Developers. So first, second, third, and fourth. So it came back with top 4 results, semantic search. Remember, in response to my question based on the source data which I had, that PDF, that shareholder data. And in this, and here what you see is the similarity score. How close is it to what I intended to search, right? And again, like I said, this is not text-based search. This is contextual and relevancy-based search. So let's look at the top result, right? In this case, and this is a chunk. This is just a part of that PDF, right? If I want to search it, for example, in our source doc, machine learning is a technology, blah, blah, blah. If I were to copy paste, go back to the shareholder data here, and Control F. So you see, it sort of captured this from this particular paragraph of this sort of source PDF, okay? And it had like four of these, and it also gives me some metadata in terms of, hey, this was from page 5, and this is the source. This is your PDF file, okay? And if I were to scroll down, and if you squint hard here, this is the question embedding. And when I say embedding, these are those, if you remember, I told you embeddings are nothing but array of floating point numbers. So this is that embedding data. In this case, and a typical sort of thing which you associate with your embedding, at least when you use them in applications, is the size of the array. In this case, it happens to be 1536, depends upon the sort of embedding model you are using, right? So it differs from that. So it's a size of, so it is an array of size 1536, essentially speaking, of floating point numbers. Just want to illustrate that, and that's why I had it here, just to make things very clear. That's all. So from first part of a demo perspective, that's pretty much it. Like I said, you can go back, try it out, and go through the source code, etc. So this was the part where we spoke about semantic search. Now, like I mentioned earlier, there are limitations of LLMs, and there are various ways, and RAG is one of those ways, retrieval augmented generation. Now, let me walk you through RAG, and I'm going to sort of deconstruct RAG so that you understand it at least at a high level, but step by step, right? Not as a big chunk. So the first part of RAG is this thing called data ingestion. So you will always do it. Like I said, I already uploaded my PDF data. It was simple for a demo. It's fine. It was simple. But typically what you do is, like I said earlier, you have your data source, could be anything. You chunk it up, split it into manageable pieces. You run them through an embedding model. You get your output, and you store them in a vector store. All good. Part 0, I mean, it's bread and butter. You have to sort of do this step as a part of your RAG application and RAG workflow. And the second part involves the end user, perhaps, or an application, even if you're using it programmatically, right? So the user enters a text input or a question, like in my case, right? That question also is run through the same embedding model, okay? And you sort of get that output array. And that output is used to query our vector database. So it's essentially comparing two arrays, if you look at it at a very simplified sort of point of view, right? And this part, again, I told you this earlier, is called retrieval. That's the R of RAG, right? Also known as semantic search. And what happens as a result of this retrieval is you get your top n results, and that's also referred to as context sometimes in this sort of generative AI architectures. And when you combine this context with the user prompt or the user input, in this case, in my example, I had, what is Amazon doing in the field of generative AI? So those top n results, those top 4 results which I had, are combined with the user input, and they are combined with the prompt. And this part is the A of RAG, augmentation or combining. And the last part is when you send this combined data as an input to the large language model. Now, this is not the embedding model. This is the large language model, the Claudes, the Mistral AIs, and the Llamas and whatnot, right? And then you get a response, right? A response is generated, so to speak. And this generation term is actually specific. It's not a generic term, right? Generative AI, right? So it's used very, very specifically by frameworks and sort of SDKs as well. So this is a specific term here. So RAG, retrieval, augmentation, and generation. So just wanted to deconstruct that for you and hope that makes sense. With that, I'm going to switch to another demo real quick, and this is sort of part 2 of the earlier one. So in part 1 we had RAG, and now I'm going to show you in part 1, sorry, I had semantic search. I'm going to sort of close the loop by showing you RAG as well. Again, not going to dive into too many details, show you the demo. Typically I do dive into, and I tend to show the code. I get very excited, but then I'm not going to do that. Too less of time here. Excuse me, I didn't want to enter Open Slack. No, excuse me. IDE, back to my IDE, and all I need to do is run the second sort of Streamlit application. And this is RAG, not semantic search. I'm going to do the same thing, the same question, obviously, just to compare and contrast semantic search and RAG. Now, this is going to take a little bit of time. Please bear with me, but what we can do in the meantime is actually go behind the scenes and see what's happening, right? I have to scroll up. I apologize, and there is a reason. I'll tell you why that's the case. So these are some verbose logs from the LangChain framework itself. I set them to true. I enabled them just so that I could show you this, right? So what is really happening? Like I told you earlier, the A of RAG, the augmentation is happening here. So if you see, this is this prompt which I set in the code. This is explicitly set in the code. You can change it, obviously. So use the following pieces of context or data to answer the question at the end. If you don't know the answer, don't hallucinate is what we are trying to tell it. Don't include harmful content. That's obviously important. And the rest of the part is actually nothing but the data from our search. So in this case, actually what I said is give me use the top 10 results to formulate your response. I want to give it more data. In the previous example, I had set the top n to 4. So in this case, it will have sort of 10 sets of data, and that's why this entire this long verbose logging. So if I scroll down, everything sort of combined here. And at the end of the day, remember, because it said answer the question. So we of course include that question, and then this is sort of giving a clue, that answer and colons, like sort of prompting the LLM. These are sort of prompting techniques, right? So that's that. If I go back here, indeed, we have the reply. So what is the response? So it says, hey, and this is, by the way, this is going to be different. I literally have no clue what it's going to say if I run it the second time, but what I know for sure that it's going to pick up the same contextual data every time. That is the deterministic part, the semantic search part. But LLMs, they do things differently at different times. It's not deterministic. There are techniques to do that, but then not in this case. So what is the response? Based on the context provided, it seems Amazon is investing in developing LLMs, which it is, and generative AI technologies, blah, 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 right? So this is the response. And I also had the semantic search results here just for context, right? So like I said, in this case, I wanted to use a richer sort of response spectrum. So I had like top 10 results. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 7, 8, 9. So yeah, that because I wanted to have the the LLM to have appropriate data. You can sort of reduce and increase it as per you have to test your applications if you were to use it there, right? Again, very simple sort of part 2 of going from semantic search to a full-fledged RAG. Now back to the presentation. Awesome. Of course, this is a conference. We have 30 minutes, simple demo, right? If you were to sort of do this at a large scale, with large amount of data for production within your company, RAG is not easy to implement, right? And I'll say it is still in its infancy, right? It's still very relatively early days for techniques such as RAG. But then if you were to think about these data ingestion pipelines, right, they itself are, have folks worked on data ingestion pipelines and sort of messaging systems, buses, right? they can be a pain, right? So just this one component of RAG can be so hard. It can be like a entire team's worth of job. But think about these other components. There are so many other moving parts: LLM orchestration, prompt engineering, augmentation. There's a bunch of other things which you're going to come across when you're going to think about implementing RAG in sort of real world production systems, right? And obviously, from my experience and from my employer's experience, obviously we are going to think of it, there are like two spectrums, right? Two large categories: DIY, which I just showed you, and this fully managed sort of experience where we say, hey, you know what, we throw out the problem to a RAG platform, so to speak, and let it sort of take care of the heavy lifting. And knowledge bases for Amazon Bedrock just happens to be one of those platforms, right? So whatever you do manually in terms of uploading your data, ingesting them as sort of creating embedding models for them, so on and so forth, it sort of takes care of the entire workflow, or rather the entire life cycle of RAG for you, including the LLM orchestration and so on and so forth. And the good thing is that Bedrock, or rather knowledge bases for Bedrock, supports multiple vector stores, right? And this is just a snapshot, current snapshot, and I'm sure this is going to grow in the future as well. So for example, there is of course OpenSearch serverless and Amazon Aurora, like I said, Postgres compatible database, but there's also other databases from other providers like Pinecone and Redis Enterprise Cloud, right? Now I didn't want to go there because I had, as expected, a demo for you, and I have 5 minutes apparently, so I'll go through this quick again. Close this. All right, so I'm in the AWS console. Do some click ops now. This should be okay. And I'm here in the knowledge bases sort of section of this Amazon Bedrock service. I'm going to click on a knowledge base which I have already configured, as you can see, and my data source here in this case is from an Amazon S3 bucket. And what I've done is uploaded a PDF document of not the shareholder letter. I've used a different example here. I have the Amazon Bedrock documentation PDF loaded in this S3 bucket, and I'm going to use that as a source for this RAG demo, right? So in this case, what I'm going to do is, right now I'm going to just test the knowledge base, right? This is not a production workflow. I've configured this. I'm going to test this knowledge base. I have selected the model, but you could sort of change this model if you wanted to. In this case, I have selected Claude 3 Sonnet, and I'm going to say, hey, I'll give it a simple one. I'll say, hey, what is Amazon Bedrock? And this is, like I said, going to be based on, remember I uploaded the Amazon Bedrock PDF user guide, the documentation, as the data source. Of course, it may or may not be able to answer Bedrock. Again, not this, perhaps other LLMs, if you depends upon their training cutoff date, right? So what it did was it came back with this sort of reply, it's a fully managed service, blah blah blah. It has unified API, etc., etc. It can help you with your fine tuning and retrieval augmentation generation technique. So let me ask this one more thing. Okay, ask one more question. What is RAG, perhaps in this case, right? So what we are having is this back and forth conversation, and none of those sort of parts are visible to you right now. Uploading data, creating vector embeddings, and so on and so forth, like it was in the previous case, right? So what you do is, and I'll show you how this is happening behind the scenes in terms of programmatic context, right? So RAG is a technique used in knowledge bases. It's generalized as well. The RAG workflow is 1, 2, 3, 4. I think it's pretty good. And there's this additional sort of, and this is not a Bedrock thing, right? Additional sort of in terms of RAG, it's very important because you might have diversified data sources, right? So typically in their responses, it is a given that a RAG sort of solution has to give you source attribution. Where did you get this data from, right? So in this case, also implemented in Bedrock, you can see like, hey, you know what? I got this sort of, I formulated this response based on the data from this source. In this case, we have just one PDF document, so it's simple enough, but this is that chunk, and so on and so forth. So it went through a couple of chunks to sort of determine this answer in this case, okay? Now, if I were to sort of show you just a quick workflow of how you would typically, and that ways you'll be able to understand like what really, what's required to set up a knowledge base, right? So you, again, give it a name, IAM permissions, it's a AWS specific security thing, give it a name, click next, and then you, sort of provide your S3 bucket. So right now, S3 buckets are supported as the data source. In future, there might be more, can't promise. So you give it your name, you give it the sort of location of your data source, in this case, an S3 bucket, you hit next, you select an embedding model, right? And then you scroll down and then you choose from a list of vector databases. If you don't, it is actually going to create a default OpenSearch serverless data sort of vector engine or vector data source for vector database for you. If you don't, of course, you can select a data source which you have a database which you have pre-configured, and you can enter all those details here, right? So I just want to give you this, and when you hit next, it's going to set up that entire pipeline. You can sync your data, and boom, off you go in terms of your RAG workflow, right? Now, if I were to go back here real quick, and and like I said, this was just what I showed you on the console right now. It was just testing the knowledge base. Of course, you won't use a knowledge base or a RAG based solution in production in that way, right? So for that, knowledge bases actually expose a couple of APIs. APIs in the context of knowledge base, they are much more. There are a lot of APIs for Bedrock. So one of them is the retrieve and generate API. So what it does is it does all of those complicated things in the bottom box, right? When you give an input, it converts that into query embedding. It retrieves all those documents, or rather retrieves all that top end results from the vector database which was configured, augments that with your initial input or question or query, goes to the LLM, combines that response, and the only interaction you have is you give it your query, you tell it what's my foundation model, and you get a response. That's pretty much it from a user experience perspective, right? And if you notice there, from a UI perspective, I had this generated response sort of enabled there. If I were to talk about the other half of the API, which is the retrieve API, it sort of works differently. It is just the semantic search part. Okay, so that's how it works. For this, if you were to use this, typically you'll have requirements around your. Apparently, I'm running out of time, so you'll have requirements around customizing your RAG workflows, and this is when you would typically use the retrieve API. Right. So thankfully, I almost finished on time. That's pretty much all I have. 30 minutes, 3 demos, all I could cover. But these areas are evolving, right? I don't think it's sort of news for you. It's nothing new. And there are lots of resources. I've just linked to a couple of them. One is generative AI course on this platform called Skill Builder. And there's, if you want to learn along with other builders, there's this generative AI space or community we have as well. Lots of sort of hands-on guides and examples there. So again, appreciate it. I'm happy to take questions in the hallway. Thank you so much for your attention.